Hello everyone, welcome to my channel on data analytics. In this video, we are going to learn about knowledge base and how we can construct these knowledge bases from the data using various learning algorithms. The outline of this video is as follows. First, we look at the history of AI, that is, how AI came into existence and how it is going to progress in the future. Next, we look at the fundamental concepts of AI. Then we look at the classification of learning algorithms that can be used for artificial intelligence. Finally, we look at philosophical questions and their answers related to AI. Let us learn the history of AI. We will use timeline to explain the origins of AI. In the beginning, computation was done under the field of mathematics. Around 1749, the German researcher has developed the field of statistics to handle the data of a state. This statistics was focused on humans, that is, empowering humans to understand the hidden information that exists in the data. In 18th century, Europe has witnessed industrial revolution. During this revolution, there existed a need to automate the industrial processes to improve productivity and to enable the work in inhabitable places, that is, very close to furnaces and so on. So, this need came into existence. Around 1871, Charles Babbage introduced computers to perform mathematical operations. During the World War period, these three fields have combined with one another and merged and evolved also. As a result, after the World War has ended, these three fields have gave birth to two new fields. First field focused on AI, that is machine centric. This field emerged by combining computers with industrial requirements. The reason is the focus of AI in the early stages was focused on how to automate the industrial processes. Similarly, in the second field, the focus was on building expert systems which are human centric. So, in this field, statistics was performed using computers to discover hidden knowledge in the data. Around 2010, people have introduced the concept of vectors and tensors. That is, any data set which can be an image or it can be a text data can be converted into vectors. For example, word to vec, tweet to vec, and so on. So the emergence of vectors and all amplified the AI field, and now AI and expert systems field were merged to give a single topic called explainable AI, where the focus was on developing artificial intelligence systems that humans can interpret. Now, let us learn the fundamental concepts of AI. That is, what is a knowledge base and how these knowledge bases were built in the early days of AI. To build artificial intelligent systems. In the early days, researchers analyzed the human beings. They observed that humans, using their sensory organs such as skin, eyes, nose, mouth, and ears, they get the surroundings information and store it in their brain. So, in this brain, they first store the information as data, later convert it into information, and then use it as a knowledge for taking decisions. The decisions can be rational, non rational, or irrational. It doesn't matter, but the entire knowledge will be stored in the brain in a particular format. Now, to build artificial intelligence systems, what people have thought of is they want to convert brain into a knowledge base where the knowledge can be stored. This can be done by converting a human into a robot with sensory organs. So these sensory organs of a robot will construct the data knowledge base, and this knowledge base can be used for decision making. So this is how they have looked at the humans and came up with the artificial intelligent beings. Now, to build knowledge base, what should be the process? So the process is first there will be a knowledge base here. So use anything from the environment can be sensed by the sensors and it will be stored in the knowledge base. Decision making will also be done in the knowledge base and it will be sent to inference engine. So any updated knowledge will be stored back here as learning and it will be used for improving the performance. So this entire architecture is called knowledge based agent. So if an agent will have these components. This is the early design of knowledge base. Now to build knowledge bases, two key questions have arisen. The first one is how do I represent the knowledge base? That is one question. And the another one is who will construct this knowledge base? This is the second question that needs to be handled. Several techniques have been introduced by the researchers to represent the knowledge base. The fundamental knowledge representation technique is logical representation. In this logical representation, we have propositional logic where we use truth values to make decisions. For example, let us say the letter P stands for oil leak and letter Q stands for tighten the valve. Now, if I make a sentence P implies Q, okay, it means if a machine detects oil leak, then it has to tighten the valve. So such kind of decisions can be automatically programmable into machines to prevent damages. A limitation of this propositional logic is that it is not expressive. To solve this problem, researchers have introduced first order logic, popularly called FOL. This is the logic that is derived from algebra, and if you are familiar with SQL, the SQL is also built on first order logic. In first order logic, the beauty is that it is concise and easy to represent our natural language. Why is it concise? Because assume we have several persons facing hungry. If I try to use propositional logic, then for each person I have to use a letter and the sentences become too much. In first order logic, we can simply say that for every x, hungry x. This way, we can represent the multiple sentences in a concise single line. The next one is the language is useful to draw inference rules. For example, assume we have two sentences where C of x states that x is a father, d of y says that y is a daughter of x. Now we say that y and z are sisters, then we can simply say that dz, that is z, is a daughter of x. So such kind of decisions can be taken. Okay, so I have explained here. First order logic is used in relational algebra. SQL in database management systems is based on FOA. Okay. Higher order logic exists to resolve the limitations of first order logic. However, we are not covering them because in majority of the cases we use first order logic and it is convenient. Now, coming to another representations, from logic, people have moved to semantic representation using is a and kind of. And then from semantic representation, people have moved to frame representation using slots and filters. Recently, from frame representation, people are pursuing research in production rules using what is the condition and what is the action. So these are the topics that are being pursued in the field of basic AI. Since the objective of this video is big data analytics, we are not going to talk about semantic representation, frame representation, and production rules. If you are interested, please search in the internet. In our video, we confine ourselves to first order logic, where we try to focus on drawing inference rules. Okay. So now we know how to represent the logic. Now the second question we have in front is how to build the knowledge base. One way to build the knowledge base is using robots. Okay. So we can assume that robots have sensors and they themselves will build the knowledge base. But the problem is we can do this in the distant future, but currently it is not possible. So the practicable option that we have right now is humans will construct the knowledge base. That is, humans will sit and will construct the knowledge base. This option looks simple and trustworthy because it is the humans or domain experts who are going to do. But the problems are it is laborious time taking, and humans may not have complete knowledge. Okay, and also if the knowledge changes over time due to concept drifts and seasonality, it is difficult for the humans to provide the knowledge base. So the final idea came up for the AI experts is, how about learning from the data? That is, I provide data to the machine, and the machine will analyze the data using various learning algorithms, and it itself will build the knowledge base. So this was the idea that people have come up with, and since then the field of data analytics came into the picture. So when you want to learn the things from the data, we simply call those algorithms as learning algorithms. So we now look at how we classify various learning algorithms. Let us look at the overall classification of learning algorithms. Learning algorithms are basically of two types. First type are called learning from logic rules. As I told you in the beginning, we use logic rules such as prepositional logic or first order logic to build the learning algorithms. The next class of learning algorithms are learning from data. In these algorithms, we use data to build knowledge base. So these algorithms are basically of three types. First one is unsupervised learning. Next one is semi-supervised learning. And the third one is supervised learning. In unsupervised learning, user will simply provide the data. He will not provide any additional data or class label. You are simply given the data, and the learning algorithm has to automatically learn from the user provided data. In supervised learning, user will provide some data and also some labeled data or metadata. The learning algorithm will make use of this data and the labeled data to build knowledge base. So these are the two basic learning methods. In between these two types of learning, there is semi-supervised learning where user will provide some information about the data, and the rest of the data will be unlabeled. The semi-supervised learning algorithms will look at this data and try to build knowledge bases. So here we only focus on unsupervised learning and supervised learning, because semi-supervised learning techniques are very close to supervised learning, because portion of the metadata is provided by the user. When we talk about unsupervised learning, we have two basic techniques. One is called rule mining or association rule mining, and the another one is called clustering. In supervised learning, we have two fields. One is classification and the other one is prediction. As I told you, in semi-supervised, we have the same categories. Now, coming to the rule mining, in this case, okay, user will simply provide the data to the system or to the learning algorithm. Learning algorithm will analyze the data and itself will build the rules, association rules, and these rules are later used for decision making purposes. For example, I will give the sales data of purchases by the customers. The algorithm will itself will analyze the data and find the rules. For example, people who are purchasing bread are purchasing jam, or people who are buying milk are purchasing bread, and so on. So such rules will be automatically generated by a learning algorithm and decisions will be taken. Similarly, in the clustering, we provide the data. For example, we are providing the different criminal cases reported in the United States. Now, once we give this data to the clustering algorithm, depending upon the attribute values, the learning algorithm will group the given data into clusters so that objects within a cluster are close to each other as compared against the objects in other clusters. In classification, user will provide the data and also the metadata or the label of the class. Now, the learning algorithms, such as classifiers, have to analyze how these attribute values are influencing this label, build the particular model, and use this model to predict the unknown data. For example, given this data, now you have to guess if the age of a person is youth, if his income is low, if the student is a student, yes, his credit rating is fair. Now you tell me whether he will buy a computer or not. So for this kind of questions, the classifier will give the result. Similarly, we have prediction. In prediction, we look at the existing data and we try to predict what the future data is going to be. This is called prediction. So, overall, please note that when we are talking about learning from data, we have only four types of learning algorithms. For example, rule mining, clustering, classification, and prediction. So, these are the four learning algorithms that we have. Why? Because we can only build knowledge bases using these four types. Okay. In the previous video, we talked about dimensionality reduction and so on. Please note that they are not learning algorithms. They are just meant to reduce the size of the data, or they are meant to improve the performance of the learning algorithms. So, the main objective of the learning algorithms is building the knowledge bases. That is why they are called learning algorithms. Dimensionality reduction techniques or data transformation techniques that we learned in the previous videos do not you be employed for building knowledge bases. So, they are not learning algorithms. So, please keep that in mind. Every technique is not a learning algorithm. Now, let us look at some philosophical questions and their answers. So, first question: do we need data for building AI systems? Please pause this video, think carefully, and choose whether the answer to this question is yes or no. The correct answer to this question is no. To build AI systems, we don't need data. Just I have told you in the previous slides, we can build AI systems using logic rules such as prepositional logic or first order logic given by the domain experts. So to build AI systems, we it is not mandatory for us to have data. Second question, do we need data for building machine learning systems? Please pause this video and choose your answer, yes or no. The answer to this question is also no. To build machine learning systems, we do not need data all the time. Some machine learning systems do not require data. For example, semantic based machine learning systems don't need the data. User can simply annotate the data and that can be used for decision making. Do we need data for building deep learning systems? Please pause the video and try to answer this question, yes or no. The answer is yes. To build deep learning systems, we need data because in deep learning systems, we have several layers of neuron networks. These neuron networks are trained using the data only. So, without data, deep learning systems will not work. So, this is the difference between AI, ML, and DL systems. Now, coming to the fourth question, try to establish the subset or superset relationship between the fields AI, ML, and DL. Please pause this video to establish the relationship between these three topics. The answer to this question is DL is a subset of machine learning, which in turn is a subset of AI. Because of this subset relationship, please keep in mind that every deep learning technique is a machine learning technique and also an AI technique. However, every AI technique or every machine learning technique is not a deep learning technique. The same applies for machine learning also. Every machine learning technique is an AI technique. However, not every AI technique is a machine learning technique. Thank you very much for viewing our video. If you liked our work, please press the like button, share it with your friends, and subscribe to our channel for more updates.